Hi, this is Dr. Eddie Morgan, and I'd like to go over the Unit 6 review for you to get you ready for our next test. Our first problem is a histogram. The histogram takes the data and presents it in a way that may be more valuable to understand. This one happens to track the number of volunteers at a shelter compared to how many hours each volunteer offered. For example, the way you read a chart like that, let's take this middle column here. If I look at the middle column here, I notice that there were, coming across from the number of volunteers, there were 8 volunteers, and each of those 8 people worked somewhere between 6 and 8 hours. And that's the nature of a histogram. Each column tells you how many people worked that range of hours. Our first question says, how many total people volunteered at the shelter this month? Well, to find that out, we simply need to find out how many worked in each category. So notice the first box, there were 7 people who worked 0 to 2 hours. There were 6 people who worked 3 to 5 hours. There were 8 people who worked 6 to 8 hours. And there were 7 people again who worked 9 to 11 hours. And finally, there were 5 people who worked 12 to 14. So if we add all that up, we find out that there was a total of 33. There was a total of 33 volunteers this month. Second part of the question asks us how many worked less than 6 hours. So less than 6 doesn't mean equal to 6, but less than 6. And so that's going to be people who worked either 0 to 2 or 3 to 5 hours. So again, we simply need to find the number in each category. So there were 7 people who worked 0 to 2 hours and 6 people who worked 3 to 5. So if we'll add those together, 7 and 6, we find out that there were 13 people then who worked between less than 6 hours this week. The last one says, how about the number of people who worked between 3 and 8 hours? So that fits into this category. They either worked in this category 3 through 5 or in this category 6 through 8. Again, we just need to count them up. So here there were 6 people in this category and 8 people in that category. So we'll add them together, 6 plus 8. So there were 14 people who worked between 3 and 8 hours at the shelter this month. The second question asks us which measure of central tendency, the mean, the median, or the mode, is most affected by an outlier and why. Best way for me to answer this is to give you 2 examples. So I'm going to give you an example that does some data that does not have an outlier. That's a data that's much greater or much smaller than the rest of the data. So for example here, 1, 2, 3, 3, 4, 5, 6. No outlier there. In the mean, we add them all up and divide by how many there are. So that's 1 plus 2 plus 3 plus 3 plus 4 plus 5 plus 6 divided by there's 7 numbers, 7. And that ends up being 24 over 7, or about 3.4. That's your mean, or what's sometimes called average. The median is simply the middle number. And so if I'm coming here and just start counting off, I can go count that one, there and there, there and there. And my median, you see, is 3. My mode, on the other hand, is there any number that shows up the most? And in this case, the number 3 shows up the most. So my mean is 3.4. My median is 3, and my mode is 3 as well. So let's look at another example with an outlier. Notice I just took the same group but changed the 6 to a 20. And that makes, obviously, the 20 is much larger than the other numbers, and that's an outlier. So if we do our mean, same calculation, 1 plus 2 plus 3 plus 3 plus 4 plus 5 plus 20 divided by 7. And you notice now we have 38 divided by 7, or 5.4. If I do my median again, same kind of situation, just cross off 1 on each side and work your way down to the middle. And you notice the median didn't change at all. The median's still 3. And likewise, the mode is still 3. So when you ask the question, which measure is most affected by an outlier, obviously it's the mean. Because notice when we put in an outlier that was much bigger, it caused the mean to go from 3.4 up to 5.4. So when you have an outlier, it affects your mean. The third problem gives us a box and whisker plot and asks us to identify the following. First off, if you want to find the minimum is the smallest. and that's way over on the left-hand dot here, and that is the number 10. The maximum is the largest. So the maximum is 75, and the median is the middle. Like the median on the street is that center area. So the median is 40. Now the other parts of the box actually divide the plot into 4 equal sections, and that's why this is called a quartile 1. The quartile 1 means that, in other words, that there's 1/4 of the data right here. There's also 1/4 of the data here, 1/4 of the data here, and 1/4 of the data here. And this is quartile 1. By the way, the median is sometimes called Q2, the second quartile. Well, quartile 1, you see, is on the number 25, and quartile 3 is on the number 55. Now the last one, IQR, is the inner quartile range, and that simply means how far is it from quartile 1 to quartile 3. So we take the numbers 55 minus 25, and the inner quartile range is 30. The fourth problem also gives us a box and whisker plot, and which is showing the number of hours of television that 8th graders watched in a week. And you need to understand again about the quartiles, that the quartiles, which divide this up here, divide this into 4 sections. And each of these sections is 1/4, or in our case, 25% of the data. So 25% of the data lies between, 25% of the 8th graders watch between 4 and 6 hours, 25% watch between 6 and 7 hours, 25% of them watch between 7 and 8 hours, and 25%, the last 25% watch between 8 and 14 hours. Now our question then is, what percent of the students watched more than 8 hours? Well, more than 8 hours is from here, from 8 and greater. So you notice that the answer is 25% of 8th graders watch more than 8 hours of TV in a week. What's the best measure of central tendency? In this case, you notice that the right side here is much bigger than the end over here. That means that this is skewed. Or it's another way of saying it's kind of like having an outlier again. So the answer to the question is the best measure for central tendency for this data would be the median, because the data is skewed, or another way of saying that it's not symmetrical to the right. So this area out to the right pulls the mean away from the center of the data. So the answer is probably median. Problem 5 presents us with a scatter plot and asks us what type of correlation is related by the data. One of the first things I usually ask students to do in a problem like this is to draw a line of best fit, like that, trying to sort of model a line that kind of goes through a lot of the points or close to all the points. And then I simply ask, is the slope of that line positive or negative? Most students would recognize, oh, that's a negative slope because from left to right, it's going down. But when we talk about correlation, what we're really asking is what happens to y as x increases. And you notice here, as x increases, y decreases, thus giving us that negative slope or negative correlation. So this would be a negative correlation. The second part asks us, what's the correlation coefficient that would be accurate for the trend line for the scatter plot? Well, when we ask the coefficient, you need to realize that first of all, it's going to be negative because it's going down. And so our choice is between 0, and let me just put some numbers here, minus 0.5 and minus 1. Minus 1 would mean that every point was on the line. That would be absolutely accurate. 0 would be all over the place and there's really no correlation. 0.5 would mean there's sort of a correlation, but it's kind of halfway. As I look at this one here and I look at it and I say, well, it's not a 1 and I think it's bigger than a 5. So in this case, as I look at that and think, well, it's not a 1 and it's bigger than a 5, I'm going to estimate that it might be about a negative 0.7. Remember, it's negative because it has negative correlation. I expect it to be bigger than 5 and less than 9, somewhere in between 6 and 8. And I put as a sample answer, no exact answer, negative 7/10. The next problem also involves correlation, but it brings in another issue, causation. does one variable cause the other variable? The premise here is that the number of hours spent studying and your grade on the Unit 6 test. What's the correlation between the data, and does one cause the other? Well, in the first case, we would say the data should have a positive correlation, which means that for every hour you study, your grade should go up. Positive, again, means that for every hour that the hours increase, my grade goes up. Notice that that would be a positive slope, and it's a positive correlation. We expect that the more you study, the better your grade will be. And the last question, though, is there a causal relationship? Does studying cause your grade to get better? And the answer would be yes. This data is a causal relationship because we believe that studying for a test causes your grade to improve. Problem 7 involves a two-way frequency table. If you notice here on the frequency table, they're taking a survey and they're comparing males and females whose favorite subject is either ELA or math. And so they put all the data into this two-way frequency table. The first question here says, what's the marginal frequency? And notice that keyword marginal, because the first thing to find a marginal frequency is identify the margins. Well, the margins here are the totals here in the bottom of the totals of ELA, math, and over here the totals of males and females. And they want the marginal total for math. Well, the marginal total for math, you see, is 168. And that's our answer for the marginal frequency of students who prefer math. The problem continues by asking us, what is the joint relative frequency of females who prefer ELA? Well, the joint relative frequency is a ratio that compares the joint frequency to the grand total. In other words, we're going to compare all the females who also like ELA to the total of the whole survey. So notice we go to our chart here. Here's the line of females, and here's the line of students who prefer ELA, and where they cross is our joint frequency, or there were 54 females who preferred English or ELA as their language. Now we compare that to the grand total. Well, the grand total is 300. And so our joint relative frequency is 54 to 300, or as a fraction, 1800ths. Finally, the problem asks us for the conditional relative frequency that a student is male, given that the student prefers math. Conditional relatives, it gives you a condition, given that the student prefers math. In other words, they're only considering students who do math. So that means it's a ratio of the joint frequency, again, how many students, male students who prefer math, to the total of the frequencies row or column, not the grand total. So in this case, it's the males who prefer math to the total people who prefer math. That's the relative conditional part of it. And so notice the males who prefer math is 92, and the total people who prefer math is 168. So my ratio is 92 to 168, or 0.54671. We'll round that off to about 5500ths is our answer. In problem 8, we're told that Jonah practices shooting 50 baskets from different distances. They've done some study with his data and modeled the data with an equation, y equals negative 2.5x plus 42, where x is the distance in feet and y is the number of baskets that are made. It asks us first to use the equation and how many baskets would we expect Jonah to make from 7 feet. Well, a pretty simple problem here. We're simply going to plug in 7 in for x in our equation. So y equals negative 2.5 times 7 plus 42. So that's going to be negative 17.5 plus 42, or 24.5. And we'll round that off and say that essentially we would expect from 7 feet for him to make about half the baskets, or 25 baskets. Second part says, using the equation again, how many do you expect him to make if he's shooting from 15 feet? Again, now we'll substitute 15 in for x. We get y equals negative 2.5 times 15 plus 42, or 4.5. Again, if we round off, we expect when he moves from 7 feet to 14 feet that he'll probably only make about 5 baskets out of 50. Question, what type of correlation does this show? Well, it is a negative correlation because as he goes farther and farther from the basket, the number of baskets that he makes goes down, and that's a negative correlation.